test. Now for your 5-6, you guys make sure that you've got colors, highlighting pairs. A lot of people did this but didn't follow directions. In section 5-6, we looked at, I think, our angle side theorem, and maybe, what else came up in 5-6? Well, let's see what happens here. When I look at number 1, in problem 1, I'm looking that this appears to be an angle side. And so I'm going to take my colored pencil on the first pair of angles, and I'm color coding that. Then I'm going to grab a different colored pencil. Yeah, this is definitely an angle side. I'm going to grab a different colored pencil and highlight the second pair of angles. There's my angle, and I can't seem to get my hands on the pencil. There we go. Angle, and then last but not least, we've got this pair of congruent sides. So this is the kind of thing that you can expect to see on your test, color coding and all. These sides in number 2, the sides don't match up in terms of, like, if you can tell here, the 2 congruent sides have the angle not a part of it, but in this other triangle, it's the included angle between those. So in this one, we'd say there's not enough info. And then just again, make sure that they're color coded. And then in number 3, I think we could take number 3 two different ways, but if I stick with what this section was about, the angle side, we could do angle side angle as well. We could do angle side angle, or SAS, but let's do angle side angle. Angle here, go ahead, London. Come up here, they're on the angle, let's go side, angle, side, angle. And I know I'm leaving out some of the other congruent marks, but that's okay. I like this one best as an example of angle. Oh, what did I just do? There we go. Angle, side, angle. Now, with your proofs, again, you guys, with some of our papers, when we see these, oh, I know. Given, these are parallel lines. PS is parallel to RT. And then the other notations is our missing triangle markings here. One of the biggest things on this one was just making sure that you're actually setting it up as a statements and reasons. And when I go statements and reasons on this one, I'm going to start looking at what potentially could I have. And right away with this parallel lines that are given, that makes me go and recognize here that I'm probably dealing with, there you go. So there's 2 parallel lines. And if we consider, and I'm just going at this with my highlighters, and then I'll use colored pencils to mark the angles and stuff. If I consider that to be the transversal, the reason I was going in and doing that is because, and we saw this on a couple other things, if I consider those parallel lines cut by a transversal, I can say that this angle here at P is congruent to this angle at T, because those guys are alternate interior angles. So I'm going to go for an angle side angle proof on this one. And I'm going to use these alternate interior angles. Then I've got a side pair. The PQ and QT are marked congruent. And then I'm going to pull vertical angles in as well and finish this up with an ASA. And so there's my plan for my proof. Now I just have to execute it. So the very first thing that I'm going to do is talk about those parallel lines and go at what information we got out of that. So that was a given. And then from that, I said that angle P was congruent to angle T. And that's because this is the definition of alternate interior angles. Definition of alternate interior angles. 2 parallel lines cut by a transversal. Alternate interior angle pairs are congruent. So that's my P and T congruence. Let me just take a colored pencil on there. P and T, I'm just going to color that light green. That's going to be my first pair of angles for my ASA. Beef your proofs up with the color coding. I'm going to grab the second given, PQ, congruent to TQ. That's given. I'm going to go and I already have those pink. I have those pink from my highlighter. So I'm just gonna, that's these guys right here. There's my sides. When we have 3 pairs, SSS is when we have 3 pairs of congruent sides. And then my 4th step is gonna be where I marked in those vertical angles. My 4th step is gonna be angle SQP. I gotta use 3 letters to name these because there's 2 angles. Angle SQP is congruent to RQT. RQT. And that is definition of vertical angles. And that was, I'm gonna go color code there. And then I can finish my proof. What was I trying to prove? Triangle PSQ is congruent to triangle TRQ. And that is by I just wrote it again. ASA. Sorry about that. I just wrote it again. That is by ASA. Angle, side angle. Something with bisecting and right angles, like number 5, is more likely to appear on your test than the parallel lines. Hear what I'm saying here? Something like the bisector and right angle in 5 is more likely to appear on your test. For this one, statements and reasons. On this one, I do believe BD bisects. So if BD is bisecting angle ADC. Okay, those are marked. Those guys are marked for me already. That idea of bisecting is marked in for us. And then the perpendicular marking is here where BD and AC intersect. Now I see this one rolling out as an ASA again. I'm going to use that idea of this bisected angle as my first angle pair. I can use reflexive for the pair of sides. And then these right angles are going to be congruent here. So I see myself doing an ASA proof on this one. So when I start out with my statements and reasons, let's just start looking at what do I need to say. Segment BD bisects angle ADC. That's given. My second step is just going to be, let's interpret that. So that makes angle ADB congruent to angle CDB. And that's just definition of bisector. Absolutely expect to see those types in there. I've got that bisected angle marked in blue on mine. There's my angle. Pull in my pair of sides. BD is BD. Just naming it for both. That's going to be a reflexive. That's my side pairs. Just color coding that. And then my last pair of angles, I'm going to bring in the second part of the given. BD is perpendicular to AC. That's given. And I'm going to take it one step further by interpreting that. Angle CBD equals 90. Angle ABD equals 90. That is definition of perpendicular lines. Meet at a right angle. Definition of perpendicular. If both of them are 90, that right there is giving me my pair of congruent angles. And I can finish up my proof on this one with ABD. Triangle ABD is congruent to triangle CBD. And that's just going to be an ASA proof. That kind is fair game for your test. Expect